Hello students, this is Neha Mathur and from today I am starting one more subject which is digital electronics, and this subject will run parallel with other playlist. And in digital electronics is very common subject or useful subject for some engineering branches, like for electronics and communication engineering students and for computer science engineering students. And this is also important for BCA students, and in some universities digital electronics, which is also known as DEC, that is digital electronics circuitry, but in some universities this subject is mentioned as LOC, that is logical organization of computers. Digital electronics is common subject for electronics and communication engineering students, for computer science engineering students and for BCA students, and in BCA it is mentioned as LOC, that is logical organization of computer. In this playlist I will teach you about digital electronics. Basically digital electronics, which is also a backbone of electronics industry, in which for electronics circuitry I can say that electronic circuitry is completely divided into two categories. First, circuits that are digital circuits, and second one is analog circuits, or I can say the circuits which operated for digital signals are said to be digital electronic circuits, or digital electronics, or digital technology, or LOC. This is a subject for this playlist. And analog electronics, all the electronic circuits which are operated with the help of analog signals come under analog electronics circuits, or I can say AEC, which is extent or application part of semiconductor electronics. And as I already started with semiconductor electronics, so in upcoming video I will also run one more playlist related to AEC. But from today I am starting lectures based on digital electronics. In digital electronics I can say that it is a branch of electronics in which all the designed electronic circuits are operated on digital signals. Digital signals, that is, I can say in the form of 0 and 1, or I can say that computer understandable language, because computer only understand binary language, that is 0 and 1. So all the electronic circuitry which is operated on digital signals comes under digital electronics, and the main basic criteria in digital electronics is designing of digital circuits. So digital electronics cover almost all the designings of digital circuits. So whenever we start with the designing of digital circuits, the basic building block of the designing of digital circuits is logic gate, or I can say that logic gates are basic building elements for the designing of any digital circuits. So today I will tell you about what are logic gates and how they are used to design any digital circuits. But before start logic gates, I will tell you about what is logic systems actually. What happens is, we have two type of logic systems. Sometimes this term creates a misconception in students' mind that is related to power supply. Basically, logic system is itself divided into two levels. The first level is positive level, or I can say positive logic, and the second one is negative logic. As I told you that in digital electronics, all the electronic circuitry deal with 0 or 1. So what happens is, here positive logic means if I am mentioning or I am considering 1 as an input, that means it is treated for high value, or I can say for on state, or I can say for true state, while 0 is represented for low value or off or false. Just example, suppose you have two values in terms of voltage which you are providing to any digital electronic circuitry, and the values are 5 volt and 0 volt. So the lower value, that is 0 volt, is always treated as 0 logic, while 5 volt is treated as 1. For some more examples, suppose you have two voltages, that is 12 volt and 5 volt. High voltage is always treated as logic 1, while low value is for 0. So what is 0 and 1 actually? For positive logic, 1 is always to indicate the higher value, or to indicate the on state, or to indicate the true situation, while in negative logic 1 is always to represent low value or off state, or I can say false state, and 0 is to represent high value or on state or true. With example, it can be easily understood, like if you have 5 volt and 0 volt, then in case of negative logic representation, 5 volt is always represented by 0. High value is always represented by 0, while low value is represented by 1. One more example, if you have 12 volt or 5 volt, then 12 volt is always for high value is always for 0, while low value is for 1. So there might be some misunderstanding related to this concept. So I am again repeating this. For positive logic level, 1 is always for high value, or for in negative logic level, 1 is always for 0 value. It is sometimes it is clearly mentioned that whether you should go for positive logic level or negative logic level whenever you are trying to design any digital circuit. But if it is not mentioned, that then by default you will have to follow positive logic level. Most of the time it is mentioned before starting designing of any digital circuitry, but if it is not mentioned, then you will have to go with positive level, in which 1 is for high and 0 is for low. Got it? So now we will start our main topic, that is logic gates. Basic building elements for the designing of any digital circuitry. In digital electronics, we will go with the designing of many more complex digital electronic circuits, but before start the designing of complex circuitry, we must have knowledge or idea about the basic building diagrams or basic building elements of more complex circuitry. So firstly we will learn about logic gates. Logic gates are basically basic elements in which we have several number of gates, or I can say small circuits, which basically used to perform some special Boolean expression. Here logic gates is categorized into 3 categories. Number 1 is basic logic gates. Second one is universal gates. There are several gates. Each gate has its own operation and symbol as well. So we will start one by one. Firstly, I am categorize them. The first category is basic logic gates, second one is universal gate, and third one is derived gate. or I can say special gates. Okay, you may write down this. Basic logic gates, in which we have firstly NOT gate, second OR gate, and third one is AND gate. These three gates come under basic logic gates category. Well, the second one is two gates that are universal gates, NAND gate and NOR. NAND and NOR, these two gates are universal gate. And in special gates, we also have two types of gate. First is XOR gate and second one is XNOR gate. X stands for exclusive, exclusive OR and exclusive NOR. So, you must have the complete idea about from here to here all the gates in terms of their symbol. What will be the symbol for a specific gate? Second one is their Boolean expression. Boolean expression which basically specify Boolean expression which specify the specific operation of the gate. While you should idea about the truth table and sometimes timing diagram. So, we will start from basic logic gate and proceed till derived gates. So, the first gate is basic logic gates. These are the basic gates with basic functionality or with the performance of basic operations of digital electronics. So, I am starting with basic logic gates, in which firstly we will discuss about NOT gate. NOT gate, which is also known as inverter. So, firstly you must have idea about the proper symbol. The symbol for NOT gate is this. NOT gate is always one input device represented by A, or whatever you want to mention you can go, but generally A is used to represent the input of digital circuits A, B, C and all, while for the output I am mentioning capital Y. So, the symbol for NOT gate is this. Now, the most important, that is Boolean expression, or I can say the operation which is performed by this gate. So, NOT gate is always invert the given input value. So, the expression for NOT gate is Y, that is output is always invert of input. It can be better understand better in truth table. Truth table is a table in which we get some outputs for specific inputs. This is the table. Here I have two columns. One is mentioning input and second is for output. Here I have only one input A and one output Y. Y is always equals to A of bar. Now, for this A, I may have two combinations of input. One is 0 and the second is 1. If I am providing 0 as an input to inverter, then according to its operation, the output will invert of its input and it will be 1. For 0 it will be 1, and if I am providing 1 as an input, then this inverter will invert the input and the output will be 0. So, what inverter is doing, inverter is just inverting or complementing the given input value in its output form. If the given input is 0, then the output will be 1, and if his input is 1, then the output will be 0. So, it is clear. Now the next is timing diagram. Timing diagram in which timing diagram, or I can say I am observing the operation of this specific gate with pulsed input. See this timing diagram, or operation of this gate when applied input is in pulse form. How? Here I have one input represented by A. Now this input, if this input is in pulse form, how it look like? It might be like this, with equal width. To make this just equal, or just to make it rough diagram, I am using dotted line, because the width of the given pulse should be equal or symmetric. So if the given input is in this sequence, then what will be the output? Here you can see or observe two levels of the input. The lower level, which is 0, and the higher level is 1. So for this interval of time, the value of input is 0. So what will be the output? As per the operation of the inverter, the output will be 1. And for this interval, the value of the input is 1. So output will be 0. Similarly, you can proceed with more and more intervals. And the next gate is AND gate. Again, first I am telling you the symbol of AND gate, which is this. AND gate is always having minimum 2 inputs and 1 output device. 2 inputs represented by A and B. These are the inputs. AND gate may have multiple inputs. But minimum 2. So 2 inputs A and B and 1 output, that is Y, and the symbol is look like this. The second one is Boolean expression. Boolean expression itself define the proper definition of gate, because this expression actually explains the proper operation of the gate. So for here, the expression or the output for AND gate is equals to multiplication of all the inputs. Here I have 2 inputs A and B. So what AND gate will do, AND gate will multiply all the inputs and provide the respective output. So this will the expression for AND gate. Third one is truth table. Truth table, I am again repeating, a table in which we have a combination of inputs to provide output. Now here we have 2 inputs A and B and one output, that is Y. Now for the 2 inputs, how many combinations in terms of 0 or 1 we will have total 4 combinations, because 2 inputs are here. So the formula to calculate the number of combinations, the number of possible combinations for the input is 2 raised to the power n. Here I have n is equals to 2, number of variables 2. So we will have 4 possible combinations for the input, and these possible combinations in terms of 0 and 1 are 0 0, that is if both the inputs are 0 0. Second one is 0 and 1. If one input is 0 and second input is 1. The third combination is 1 0 in which first input is 1 while second is 0, while the fourth input in which both the inputs are 1 1. So in first case both the 0 0, in fourth case both the 1 1, in second case 1 0, this one is 1, and in third case just opposite, that is this one is 1 and this one is 0. So what will be the output? Output is multiplication of respective inputs. So for the first combination, when both the inputs are 0 0, output will be 0, because 0 into 0 is 0. Now with next combination, when first input is 0 and second input is 1, 0 into 1 again 0. Now with third, when first input is 1 and second input is 0, the multiplication will 0, and with last input, that is 1 1, when both the inputs are 1, output will be 1. Now I can properly define what actually AND gate do. When both the inputs are high, then only this gate will provide proper output in terms of high value. Instead of both the values in terms of high, if any one of the input is low or 0, the output will be low. So if you want to define, you can define in this manner in terms of the combinations of input, and with the proper definition you must have idea about the symbol and Boolean expression as well. Now the next is timing diagram for this gate and timing diagram. Here you have two inputs. So first input is A and second one is B. Now the sequence of the input depends up to you. If you want to go with 0 0, 1 1, 0 1 0, or you want to go with 1 1 0, 1 0 1 0, any one of the combination or some more, you can choose any one. According to this sequence, you will have to draw the pulse in proper sequence manner. Like I am taking this as a and this sequence as a B. 1 2 3 4 5 6 7 digits. You may go with less or more. 1 2 3 4 5 6 7. No, so now I am drawing a pulse for A, C, 0. So starts from 0 and 0, again 0. Next, for two next intervals, the value is 1. For next interval, the value is 0. Now again 1 and again 0. I am again repeating. Before start, draw the timing diagram. It is necessary to plot such kind of dotted line so that you can get at least symmetricity in terms of accuracy. And the next sequence is for B. You may change if you want. I am again repeating, it is up to you, it depends on you. 1 1, so it will start from 1 1 1, third 0 1 0 1 and 0. This is the sequence for B. Now for this sequence and this sequence, you will have to find the value of Y, that is output, which is nothing but the multiplication of A and B. So now start with this interval. For this interval, the value of A is 0 and the value of B is 1. So 0 into 1 will be 0. So for this interval, output will be 0. Now come with next interval. In this interval, the value of A is 0 and the value of B is 1. So 0 into 1, again 0. Now for the next interval, the value of A is 1, but the value of B is 0. So 1 into 0, again 0. Come with next interval, the value of A is 1 and the value of B is also 1. So 1 into 1, it will be 1. With next, 0 into 0, again 0. 1 into 1, again 1, and 0 into 0. So the proper timing diagram, or I can say the proper operation of AND gate when input is in pulsed form can be understood with the help of this particular diagram. Now one more thing, AND gate is a multiple input device. So if you have more than two inputs, the symbol with multi-gate input, or I can say multi-gate and gate, the symbol will be the same, but output may be A, B, C. If we are talking about 4 inputs, it will be A, B, C and D, and in this case the output will be multiplication of all the inputs. So if I have 3 inputs, the Y will be A into B into C. If I have 4 inputs, A, B, C, D, then the output will be A into B into C into D. This is the Boolean expression for multi-input gates. This is also the Boolean expression. Symbol is still mentioned, and if I am talking about the truth table, you can just take the proper possible combinations of the input in terms of 0 and 1 and verify the respective output in terms of 0 and 1. So symbol, Boolean expression, truth table, timing diagram, and if the gate is possible with multi-gate and multi-inputs and gate, multi-inputs. Hope it is clear. Now we will go with third gate, that is third basic gate, which is OR gate. Now the next basic logic gate is OR gate. Again, firstly I will tell you what is the actual symbol for OR gate, and the symbol for the OR gate with 2 inputs looks like this. 2 inputs represented by A and B. I am again repeating, this type of representation is not an compulsion. If you want, you may go with X, Y, P, Q, whatever you want to go, but generally in almost all the books the inputs are represented by A, B, C and so on, and the output is represented by Y. This is 2 input OR gate. The second thing is its Boolean expression, and the Boolean expression for the OR gate is Y is equals to, in terms of input, it will be A plus B. What OR gate is doing, it is just adding the respective and supporting combination of input. Now this expression is clear with truth table, in which we will have possible combinations of input in terms of 0 and 1. For inputs, here outputs. How many inputs? 2, A and B. Output is Y. Again, for the 2 possible inputs, we will have 4 combinations in terms of 0, 0, 0, 1, 1, 0 and 1, 1. Now, for the first combination, when both the inputs is 0, 0, then Y is equals to 0 plus 0, it will be 0. Second, when first input is 0 and second input is 1, 0 plus 1, it will be 1. For third input, third combination, when first input is 1 and second input is 0, it will be 1 plus 0, 1. And when both the inputs are high, that is which is 1 and 1, then according to OR operation, 1 plus 1 is equals to 1. While in simple binary arithmetics, 1 plus 1 is always equals to 0 with carry 1. This we will discuss later. Just remember that in binary arithmetics 1 plus 1 is always 0, while for OR operation 1 plus 1 is always equals to 1. So to proper define OR gate, you can say when any of the input is high, out of 2 if any one of the input is high, or When both the inputs are high, then output will be high. Like in this case, one input is high, here one input is high, here both the inputs are high. So at least one input should be high to get high value or true condition for output. Okay, so this is truth table is basically used to define the proper definition or the proper operation by considering individual cases for individual combinations of input. So the symbol is clear, this is the expression and this is the truth table. Now the time to design timing diagram. Timing diagram for OR gate. OR gate. The next is timing diagram. Again, I will have two inputs A and B. The sequence of the pulse is up to you. Here I am taking 0, 1, 1, 0, 1, 0 for the A. Dotted line just to try to make it symmetric. Okay. Now the next sequence for B input, which is 1, 0, 0, 1, 0 and 1. Now for this specific sequence of input, we will have to draw the pulse output or pulse for particular output. Now what will be the y? Y is A plus V. Starts with first interval. For first interval, the value of A is low, that is 0, and the value of B is 1. So when we add 0 and 1, 0 plus 1 will be 1. So it will start with high value. For the next input, the A is 1 and B is 0. So again 0 plus 1, 1. For next combination, A is 1 and B is 0. So 0 plus 1, again 1. For next interval, A is 0 and B is 1. 0 plus 1, again 1. For next, 1 and this one is 0. 1 plus 0, 1. And for next, 0 plus 1, 1. So the output from first interval to last interval, the output is in its high form or in its true form. If I am considering this diagrams for positive logic level system. OR gates are also available for multi inputs. So the next is multi inputs OR gate. The symbol will be same, only instead of using two inputs, we may have more than two inputs, which is represented by ABC, or if we have 4 inputs OR gate, that will be ABCD. ABCD. And the output expression is same, that is the addition of all the inputs. Here I have 3 inputs, so the Boolean equation will be A plus B plus C. And for the 4 input OR gate, the equation will be A plus B plus C plus D. Now as per this sequence or as per this Boolean equation, you may go with the designing of truth table. Here for this combination or for this 3 input OR gate, you will have total 2 raised to the power 3, that is 8 possible combinations of input in terms of 0 and 1, while for ABCD you will have 2 raised to the power 4, that is 16 possible combinations for inputs in terms of 0 and 1. Now the next gate is universal gates, in which we have 2 gates. The first is NAND and the second is NOR gate. here the first thing is why these gates are called universal gate, since whether it is NAND gate or NOR gate, with the help of NAND gate as well as NOR gate, all the others remaining gates that might be basic logic gates or upcoming derived gates, the operation of all the remaining gates can be executed with the help of this or this. This is the reason these gates come under universality category, because they prove their own universality in terms of designing of execution of all the other gate with the help of their own Boolean expression. So I will start with NAND gate. Firstly, you must have the idea of the symbol. See here, the NAND is nothing but a AND gate which is followed by N, and N is for NOT. So what will be the symbol? The symbol starts with AND gate symbol like this, with two inputs A and B, but followed by NOT. So one bubble is marked and Y is output. Or the same execution is possible with another symbol, and the next symbol will be AND followed by NOT like this. So both the symbols are for the representation of Boolean expression of NAND, but the specified symbol for the NAND gate is this. Now the next Boolean equation. Boolean equation which basically defines the complete operation of specific gate, and here for the NAND gate the Boolean equation is multiplication of all the inputs with its complement. So Y is equals to A dot B, that means A multiplied by B with complement. This is the Boolean expression for NAND gate. The third is truth table for two inputs. Truth table. The first row is for inputs and output. Here I have two inputs A and B and one output, and the output will be in terms of AB, A dot B with complement. Now the possible combinations for two input is 0, 0, 0, 1, 1, 0 and 1, 1. Now start with first combination when both the inputs are 0. 0 into 0, it will be 0, and the complement of 0 is 1. Next, when A is 0 and B is 1, 0 into 1, 0, and the complement of 0 is 1. Third combination when first input is 1 and the second input is 0, 1 into 0, 0, and the invert or complement of 0 is 1. With last combination where both the inputs are high, which is 1, then 1 into 1, 1, and the complement of 1 is 0. Now in order to define the proper description of the NAND gate, I can say that when both the inputs are low or any one input out of two is low, then the output will be high, and when both the inputs are high, output will be low. This is the proper explanation of NAND gate, which can be defined after drawing truth table. Now next is timing diagram for NAND gate. Timing diagram, or I can say the proper explanation of the operation of NAND gate with pulsed input. Here you have A and B two inputs in pulse form, and the sequence of the pulse depends on you. I am starting from A, B, A, when A is 0, 1, 0 and 1. Just mentioning 4 intervals. Now for the symmetricity, I am marking dotted line. Now take B as second input. I am starting this from 1. The next is 0, again 0 and 1. This is the sequence of A and B. Now Y, which is multiplication of both the inputs with complete complement. So for the first interval, when A is 0 and B is 1, 0 into 1 0 and the complement of 0 is 1. For the next interval, when A is 1 and B is 0, 1 into 0 0 and the complement of 0 is 1. So the next interval is again followed by 1. For the next interval, when A is 0 and B is also 0, 0 into 0 0 and the complement of 0 is 1. And for the last interval, when the A is 1 and B is also 1, 1 into 1 1 and the complement of 1 is 0. So end with the value of 0. This is the timing diagram for NAND gate. And the next is multi-input NAND gate. Multi-input NAND gate. Multi-input, the symbol will be same, only the difference will with the number of input. Instead of 2, here we will have more than 2 inputs, A, B, C. Now output will be Y. And the Boolean equation is the multiplication of all the inputs with complete complement. Or if I am talking about the NAND gate with 4 inputs, the inputs will be A, B, C, D and the equation will be A dot B dot C dot D with complete complement. Now if you want to go with the truth table of respective expression or symbol, here for the 3 inputs you will have 2 raised to the power 3, that is 8 possible combinations of input in terms of 0 and 1. While here for 4 inputs you will have 2 raised to the power 4, that means 16 possible combination of input in terms of 0 and 1. So NAND gate is clear with its symbol, Boolean expression, timing diagram, multi-input NAND gate and truth table also. Now the next gate is NOR gate. Again the NOR gate is also a universal gate because all the other basic gates, whether it is NOT, NOR, whether it is NOT, OR, AND, NAND or other derived gate, all the gates can be executed with the help of NOR as well as NAND. So now the next is NOR gate. NOR, in which we have OR followed by NOT. So the symbol for the NOR gate is OR followed by NOT, and for the indication of NOT, bubble is used. Here I have 2 inputs A and B and the output is Y, or the equivalent combination of the symbol will be OR followed by NOT, A, B and Y. This is the symbol for NOR gate. Now next is Boolean equation. Boolean equation in which output, which is Y, is the addition of all the inputs with complete complement. So Y is equals to A plus B with complete bar. If we will have 3 inputs, then it will be A plus B plus C ka whole bar. Now next is timing truth table of NOR gate. Truth table. First row is for inputs and output. I have 2 inputs A and B and 1 output which is A plus B with whole bar. Okay. So the possible combinations of input 0 0, 0 1, 1 0 and 1 1. Now starts with first combination where we have both the inputs 0 0. So when 0 plus 0, it will be 0 and the complement of 0 will be 1. For the next in combination, when A is 0 and B is 1, 0 plus 1 is 1 and the complement of 1 is 0. For next 1 plus 0, it will be 1 and the complement of 1 is 0. And 1 plus 1 is 1 and the complement of 1 is 0. So in order to define in proper description, you can say that only when both the inputs are low, then NOR gate provide high value of output. Otherwise, if only one input is high or all the inputs are high, then output will be low. So when output will high, only when both the inputs are low. Or if any one of the input is high or all the inputs are high, then output will be low. Now next, that is multi-input. No, firstly I will tell you timing diagram. For the two inputs A and B, the combination I am taking here 0 1 0 1. Again dotted part to maintain the symmetricity, and the sequence of B is 1 0 1 0. Okay. So what will be Y? Y is A plus B with whole bar. So for the first interval, when the A is 0 and B is 1, 0 plus 1 1, and the complement of 1 is 0, so we will start with 0. For the next interval, when A is 0, A is 1 and B is 0, 0 plus 1 1, and the complement of 1 is 0. So the next interval is again followed by 0. For next, when A is 0 and B is 1, 0 plus 1 1, and the complement of 1 is 0, again 0. I should mention 0 here. For next, when A is 1 and B is 0, 0 plus 1, I think I should take it 1, just to make it clear for you. Otherwise you may go with 0 also. 1 plus 1, it will be 1, and the complement of 1 is 0. No difference. Same. The complete output for all the intervals is 0. It is up to you. It is your choice for what sequence you want to go. So for my sequence or for my selection of the sequence, the output will be like this for first to fourth interval with 0 value. So the next is multi-input E, that is multi-input NOR gate. Multi-input NOR, in which we will have NOR followed by more than two inputs represented by Y, and the expression will be addition of all the inputs with complete bar. Similarly, if I am talking about 4 inputs A, B, C, D, and the output will be A plus B plus C plus D with complete bar. Now for truth table, for 3 input NAND gate, you will have total 8 combination, and here you will have 16 combination in terms of 0 and 1. So NOR gate is in terms of symbol, Boolean expression, truth table, timing diagram, and multi-input NOR gate. These are the basics of the gate, because whenever we will go with the designing of complex circuitries, these will be the basic element of the designing. So hope you all are clear with this. Now the next, third category of the logic gate is derived gate. Third category, derived gate, or I can say special gates. Why these are called special gates? Because these are the gates, with the help of them we can perform some special operations. How? You will see. Firstly, under this category we have 2 gates. The first is XOR, exclusive OR, and the next is XNOR. So we will start with XOR, or the same representation for XOR is XOR. Okay, XOR, XOR and exclusive OR. Now first the symbol C, symbol for this gate looks like this. The back section is like OR, and the upper layer makes it special or makes it different from other gates. The representation of exclusive OR gate is like this. Okay. Now the Boolean expression, which itself prove, I can also write Boolean equation or expression, whatever you want. This equation will prove why this comes under the category of special gates, because the output will be A, first input, XOR special symbol with B, and the simplified form of this expression looks like A bar B plus A B bar. So the expression itself clears that this gate is designed to perform some special task. Here you can see when A is XOR with B, the simplified form looks like A bar B plus A B bar. So this is the Boolean expression. Now the next, after Boolean expression, truth table. The method will be same. First inputs, then output, input with two combination AB and output Y. Here I have 4 possible combinations for 2 inputs 0 0 0 1 1 0 and 1 1. Now starts with first combination when both the inputs are 0 0. Just to make it easier, I am mentioning firstly the expression. This is the expression for output. Now start with first combination when A is 0 and B is also 0. So when A is 0, A bar will be 1 dot B, and the value of B is 0 plus A, which is 0, multiplied by B bar, and B bar will 1. So 1 into 0 0 plus 0 into 1 0 and 0 plus 0 0. So for the first combination output will be 0. Now come for second combination where A is equals to 0 and B is equals to 1. When A is equals to 0, what about A bar? A bar will be 1 multiplied by B, and the value of B is 1 plus A is 0 multiplied by B bar, and the value of B bar is 0. So 1 into 1 1 plus 0 into 0 0. So 1 plus 0 1, and the output will be 1. Okay. Come with third combination where A is equals to 1 and B is equals to 0. When A is 1, what will be A bar? A bar will be 0. B is itself 0, A is 1 and B bar is 1 because of the complement of 0. So 0 into 0 0 and 1 into 1 1, and the 0 plus 1 is 1, so output will 1. Now with last combination, which is with the high value of A and B. When A is 1, A bar will be 0, B is itself 1, A is 1 and B bar is 0. So 1 into 0 0, 0 into 1 0, 0 plus 0 0. So what is the conclusion? The conclusion is when any one of the input out of 2 is high, then only output will high. Meanwhile, if both the inputs are low or both the inputs are high, then output will low. So XOR gate will provide high value of output in terms of 1 when any one input out of 2 is high. Okay. Next, timing diagram. and I hope now it is clear to all of you to draw the timing diagram. When if you follow the proper sequence of the supportive input, then it is easy to draw timing diagram. Practice it and draw. So the next important topic for under XOR gate is multi-input XOR. Multi-input, the symbol will be same, only more than 2 inputs. For 3 inputs A, B, C, the output will be A XOR B XOR C. If I have 4 inputs, D is also here, then it will be XOR of D also. Okay, so symbol Boolean expression, that is for 2 inputs, I am again repeating A XOR B. For simplification, A bar B plus A B bar. Truth table and multi-input gate also. And if you want to simplify this or simplify 3 inputs, then see, if it is A XOR B XOR C and Y is equals to this, so first take any 2 inputs. Suppose I am taking this. So what is the simplest expression for A XOR B? This is A bar B plus A B bar. Write it down for this and repeat the remaining section. Okay. Now again you have 2 expression. First XOR second. So what will be the simplified form? Simplified form will be first expression with complete bar, second expression as it is, plus first expression as it is with second expression bar. This is the simplified form of if we have 3 input XOR gate. Okay, same will with 4 input. If we have 4, then simplify this with 3, and with 1 more XOR you can simplify next. But it is sufficient to all of you if you are clear with max to max 3 inputs. Otherwise for special gates 2 inputs are sufficient, but just to make it clear, go with, at least for the practice, go with 3 inputs. Okay. Now the next special gate is, after XOR we have one more special gate, which is XNOR or XNOR. Okay, first symbol, and the symbol is when XOR gate is followed by a bubble, it becomes XNOR. For 2 inputs, I am again repeating, when XOR gate is followed by a bubble, it's become XNOR and output is represented by Y. Now the most important Boolean equation. Here the equation will be A XOR B with complete bar, and the simplified form for this expression is AB plus A bar B bar. See the difference. In XOR we were this A XOR B, while in XNOR, where XNOR is just followed, XOR is followed by bubble, and for bubble I am marking complement of the output. So the simplified form will look like this, AB plus A bar B bar. Now how it comes from here to here, this will clear once I will tell you about complete detail of Boolean algebra. We will discuss in next video. Once I will tell you about the Boolean algebra related to digital electronics, then it will easier to you to all of you to understand how this expression become easier in term of this. Okay, for today or for this situation, just remember that for the XOR gate, for the XNOR gate, the expression is A XOR B with complete bar, and the simplified form is AB plus A bar B bar. Okay. Now next, truth table. TT, truth table. Draw the table. Inputs, output, 2 inputs, A and B, 1 output Y. Possible combinations of input, 4. Now you have to find the output. I am mentioning the expression. Then we will evaluate the proper output with respective combination of input. If I am talking about first combination, when A is 0, B is also 0, what will be the output? See, A is 0 multiplied by B, which is also 0, plus A bar B bar. A bar is 1, B bar is also 1. So 0 plus 1 is 1. So it will be 1. Now come with second combination. When A is 0 and B is 1, A is 0, 0 multiplied by B, which is 1, plus A bar. When A is 0, A bar will be 1, and when B is 1, B bar will 0. So B into 0 into 1, 0, plus 1 into 0, 0. So it will be 0. Next, when A is 1 and B is 0, A is 1, B is 0, A is 1, so A bar will be 0, or B is 0, so B bar will 1, and 1 into 0, 0, 0 into 1, 0, so it will be 0. Now the last combination in which A is 1, B is also 1, so 1 into 1 plus 0 into 0. It will be 1 plus 0, that is 1. So just opposite to XOR, here we will have high value of output when whether both the inputs are low or both the inputs are high. If any one of the input out of 2 is high, then output will low. This is the proper definition of XNOR gate in terms of its output calculated with the help of supportive combination of inputs. Now the next, try to draw timing diagram. Concept will be same, and the next is multi-input NOR, XNOR. Same symbol followed by bubble. 3 inputs A, B, C, and the output will be A XOR B XOR C with complete bar. Okay, and again how it can be write for A XOR B, for this A XOR B, you can write for this section, you can write A bar B plus A B bar, okay, followed by C, and the complete bar is following. Now again solve this expression where first expression is following the bar because of XOR, second expression will remain the same, plus first expression will be the same and second come with bar, and this expression is following complete bar, so like this. Okay, it can be become more simpler actually, but I am again repeating that you must have idea about the Boolean laws, and when I will clear all the terms related to Boolean law, then it will be easier to simplify this kind of complex equations. Till now just remember Y is equals to A XOR B XOR C with complete bar. Okay, so NOR gate is again in terms of symbol, Boolean expression, truth table and multi-input NOR gate. Now the basic logic gate with with OR, NOT and universal gates in terms of NAND and NOR, and derived gate, XOR and XNOR. These all 3 plus 2 plus 2, 3 to 5 to 7, 7 gates I explained in terms of symbol, Boolean equation, truth table, sometimes timing diagram, and if required multi-input respective gate. So clear with these all individual parameters for all the gates. And the second thing is try to draw all the timing diagrams just to make to become more familiar with all these things. And logic gate is complete. In next video I will tell you about the Boolean algebra and Boolean laws related to digital electronics. So please follow the content and hope you are following the content. If you are following, please consider to subscribe my channel and click on bell icon to get updated for upcoming videos, and share this link with your friends also. And for the link of previous videos, you can get the link from here and from the description also. And thank you so much.